Hi, maths students. It's Mr. Hajkasim here, and today we're going to learn how to complete the square. And this is a helpful skill in order to be able to solve quadratic equations. Now, before we start, I just want to do a recap on two skills. Firstly, we have the square, x squared is equal to 16. So what is the value of x? Now, should be quite straightforward. We should be able to recognize that 4 squared makes 16. But if we were to solve this using algebra, we would have to take the square root of both sides. So x will be equal to the square root of 16. X is therefore equal to 4. Now, with this in mind, we have to also remember that minus 4 squared will also give us 16. So another way of rewriting this could be x is equal to the plus minus square root of 16, where x is equal to either 4, and in fact, I'm just going to cross that out. We can say x is therefore equal to 4, or x is equal to minus 4. Likewise here, we've got x squared equals 25, so x is therefore equal to the plus minus square root of 25. X is therefore equal to either 5 or x is equal to minus 5, because minus 5 squared gives us 25, 5 squared also gives us 25. Right, now the next step would be to be able to solve quadratic equations like this. I'm just going to rub out what I've done so far, so clear all drawings, and let's have a go at solving this then. To solve this, what we need to do is think about two numbers that add to give us 5, and the same two numbers that multiply to give us 6. Well, the factors of 6 are 1 and 6, but 1 and 6 won't make 5. We've also got 2 and 3. Now, 2 times 3 will make 6. 2 plus 3 will also make 5. So these numbers work, satisfy the conditions that we're looking for. And then we can rewrite this as x squared plus, we'll break the 5x down into 2x and 3x. So these are the numbers we found over here. So x squared plus 2x plus 3x plus 6 is equal to 0. And then what we need to do is factorize this half of the equation and then factorize the other half. So the highest common factor here, they both have an x. So the highest common factor goes on the outside. Inside the bracket, we'll have x plus 2. And if we were to expand this, x times x makes x squared, x times 2 makes 2x. Likewise here, the highest common factor is going to be 3, because 3 goes into 3x and 3 also goes into 6. So we will have 3 on the outside, x on the inside, plus 2. Now, what we need to do is bring down one of the brackets. So that's going to be x plus 2, and then collect these two terms together or add the two terms together. So what we'll end up with is x plus 3 in the other bracket, which is also equal to 0. Therefore, x is equal to minus 2 or x is equal to minus 3. So using this method, we're able to find the values of x by solving this quadratic. Now, moving on to what we're going to do today. So if we have a look here, we have x squared plus 6x plus 7. Now, the method we just did to solve the previous quadratic is not going to work, because I can't think of two numbers that will add to give me 6 that will also multiply to give me 7. The only factors of 7 are 1 and 7. 1 times 7 makes 7, but I can't add 1 and 7 to get 6. So that is not going to work. So this is where we use the completing the square method. Now, I'm going to use some geometry to try and explain how we complete the square. So let's break these terms down into rectangles and squares. So x squared can be drawn as a square here. 6x can be drawn as a rectangle. and 7 can be drawn as another rectangle. Now we can label these. So the length of side here for this rectangle has an area of x squared, therefore the height is going to be x and the width of the square is also going to be x. With the rectangle, it has an area of 6x. Now notice that this side here is equivalent to this side, so the height is going to be x and the width is going to be 6, and this square here has an area of 7, so we can just pick any two numbers because we're not going to be too concerned about this rectangle, I should say. So we can have 3.5 and 2. Just one thing, bear in mind these rectangles and squares aren't drawn to scale, but this is just a process to see how we would complete the square. Now, once we've done this, what we want to do is half this rectangle here and merge it onto the square. So we want to merge this rectangle with an area of 6x onto the square. But first we're going to half the rectangle. And if we half the rectangle, what we'll end up with is 2 rectangles with the heights of the rectangles aren't going to change. Just going to draw them here. So the height is still going to be x. But as we've halved this rectangle, the width is going to be 3, and the width of the other rectangle is also going to be 3. So we're going to have 2 rectangles with height of x and width of 3. And we want to merge these two onto the square here. So what we'll end up with is something like this. So we've merged it vertically and we've merged it horizontally. Now, let's think about the height or the length and the width of this shape that we formed. So if I just start labeling the sides, and what I'm going to do is rub this out so we don't get confused. All right, so this is the square with area x squared. So the width is going to be x, and the height from here to here is also going to be x. Now, these two rectangles that we've merged are the ones that we talked about earlier. So this one has a height of x and a width of 3, could be 3 centimeters, 3 meters, doesn't really matter. Likewise here with this rectangle, its width is going to be x, but its height is going to be 3. So what we have is this shape here. It's not fully a square, but we can turn it into a square, or we can complete our square like this. Now, if I just rub this out. Okay, so now to find the area of this shape here, to find the area of this square here, what I need to do is multiply the base by the height. Well, the distance of the base is going to be x, so this distance plus 3 multiplied by the height, which is also going to be x plus 3. So we would do x plus 3 multiplied by x plus 3 to get the area of the whole square, which also includes this region here. So rather than writing x plus 3 times x plus 3, we can just write x plus 3 squared. However, what we want is the area of the shaded region in gray. So what we need to do is subtract this much away from the whole square. So if the whole square has an area of x plus 3 squared, we want to take away this much from it. Now, the width of this square is going to be 3. The height of the square is also going to be 3. 3 times 3 makes 9, and just use a black pen. So this area is 9, so we want to subtract this area from the whole square to get the area of the shaded region. So what we would do is x plus 3 squared minus 9. And we've dealt with this, and we've dealt with this, and then we have this rectangle here, and we just need to add on the 7 And what we'll end up with is, and I can continue with a black pen, x plus 3 squared minus 9 plus 7 is going to be minus 2 equals 0. And this would be your answer if you were to ask to complete the square. Now, once we've done this, we could actually solve this equation to find the value of x. And I'm going to do this on the next slide. So if I just clear everything that we've done, and if we go on to the next slide. So what we had was, and in fact, before I solve this, I'm going to explain how we can complete the square without using the diagram. So if we think about the general equation of a quadratic, so all quadratics are written in the form of ax squared plus bx plus c. And what our answer was x plus 3 squared minus, what did we end up with? It was minus 9 plus 7, which was minus 2 equals 0. So what we essentially did was x plus, think about this 6 here. This 6 becomes a 3. So what we do, and 6 is b. So 6 is the coefficient of x. So what we did was x plus b divided by 2 squared minus the square of 3. So initially what we had was x plus 3 squared minus 9 plus 7 equals to 0. So we were subtracting 9, and the reason why we were subtracting 9 was because we had b over 2 squared. So again, b is 6 over 2 squared. So 6 over 2 is 3. 3 squared makes 9, and then plus c. So this is how you would complete the square, or this is the general formula of completing the square. Now, I prefer to understand what we're doing, but if you like a formula, this works perfectly fine as well. So if we apply this to what we have here, we'll end up with x plus b is 6. So 6 divided by 2 is 3. 3 squared minus, again, b is 6. So 6 over 2 is 3. 3 squared is 9. Plus c, and c is 7. Plus 7 is equal to 0. So what we have now is x plus 3 squared minus 2 is equal to 0. Now to solve this, what we need to do is isolate x. So we will get rid of this minus 2 by adding 2 to both sides. And that will give us, or leave us with x plus 3 squared equals 2. To get rid of this square, we have to take the square root of both sides. So we're going to be left with x plus 3, and in fact, I'm going to delete the brackets now. And there we go. X plus 3 is equal to the plus or minus square root of 2. This is what we did for the starter. Now, the last thing we need to do is take away 3 from both sides, because we want to get rid of this positive 3, or the addition of 3. So what we're left with, x minus 3 cancel out, 3 minus 3 will cancel out. So x is equal to minus 3 plus the square root of 2, or x is equal to minus 3 minus the square root of 2. Now the reason why we get 2 solutions for x is because we have to take the positive square root, as we've done here, and then we would also have to take the negative square root. So this bit here, this is testing your ability to solve for x, essentially. So let's do one more example, and I'm just going to rub all of this out. and moving on. So the question says here, write x squared plus 8x plus 5 in the form of x plus a in brackets squared plus b, where a and b are integers. So if we're asked to write this quadratic equation in this form, we're essentially asked to complete a square. So what I can do is use geometry to have a go at this, and then use the formula to have a go at this. So again, we can draw ourselves a square with an area x squared, so the length of sides is going to be x and x times x makes x squared, and then we're going to have a rectangle. Again, these are not drawn to scale, so apologies. We can say this width is 8 and this height is going to be x plus 5, but we can just really ignore this. We can have 2 or 2.5 and 2.5 times 2 makes 5, 8 times x makes 8x. And then what we need to do is split this rectangle into 2 halves and merge it onto the square. So what we'll end up with is our square with length of sides. Actually, I'm not going to draw the length of sides or write the length of sides just yet, plus this rectangle split into 2 halves. So our height is still going to be the same, but the width of each rectangle is going to be half of the width here. But if we were to work out the area, this is still 4x, and the area of this rectangle is still 4x. 4x plus 4x makes 8x. Now, what we need to do is merge these onto here. So what we'll end up with is a square like this. We can add one on the top, and we can add the other on the side. And this is the shape we create. Now, the length of side for the square was x, and the length of side, or the width of the rectangle, was 4. This side is also going to be x, and this width here, or this height here rather, is also going to be 4. So now I'm just going to use a different color pen. And if we were to work out the area of the whole square, which includes this region as well, we would have to do the base multiplied by the height. So the base is going to be x plus 4 squared. Well, the base is x plus 4, the height is x plus 4. So if we multiply the base and the height, we're essentially squaring x plus 4. So the area of the whole square will be x plus 4 squared. However, what we want is the area of these regions here. So what we need to do is take off this amount that I've drawn around in red. Now this square here, and I'll color it in green. So the green square has an area of, well, to find the area, we need to do the base multiplied by the height. The base of this green square with a red outline is going to be 4. The height is also going to be 4. So the area is going to be 16. 4 times 4 will give us 16. So we need to subtract this away from the whole square to get the area of the shaded region, the area of the shaded region being the red area, minus 16, and then we had a 5 plus 5 equals 0, and then this will simplify to x plus 4 squared minus 11 is equal to 0. And this is our answer. So we've written it in this form as they've asked us. And if they were to say, state the value of A, well, A is equal to 4. This is our A value, and B is going to be minus 11. And if we were to use the formula, well, we said the formula is x plus half of B. So half of B is going to be 4. squared minus half of b squared. So half of b is going to be 4. 4 squared is going to be 16, minus 16 plus 5 equals 0. And that will still leave us with x plus 4 squared minus 11 is equal to 0. And then we can solve this equation using our knowledge of algebra. So I'm just going to rub out what I've done here just to give us more areas to work with. All right. So to solve this, we want to isolate x, get x on its own. So we would have to get rid of this subtraction of 11. We can do that by adding 11 to both sides. So what we'll end up with is x plus 4 bracket squared is equal to minus 11, and 11 cancel out. 0 plus 11 is 11. Then we want to get rid of this square, so we'll take the square root of both sides. So what we'll end up with is x plus 4 is equal to the plus or minus square root of 11. Remember, this and this cancel out. And then x, to isolate x, we need to subtract 4 from both sides, because we're adding 4. So to get rid of this addition of 4, we have to take 4 away. So the addition of 4 and the subtraction of 4 cancel out. X is equal to minus 4 plus the square root of 11, or minus 4 minus the square root of 11. And these would be our two solutions, and I can write x, or x is equal to, write that a bit nicer, or x is equal to 4 minus the square root of 11. All right, let's do one more example. And if I just clear all of the drawings. All right, so again, this is a completely square problem because they're asking us to write, for all values of x, find the value of p and the value of q. So again, as they've given it to us in this format, we need to complete the square again. So we can do the quick method. So this is b, so we'll have x plus half of b, which is 3 squared, minus half of b squared. So half of b is 3, 3 squared is 9, minus 9, and then we have the minus 2 is equal to 0. So this is going to be x plus 3 squared minus 11 is equal to 0. And find the value of p and q. So p is equal to 3 and q is equal to minus 11. All right, and that would be our answer. And again, if we were to solve this, we would just use algebra to solve this equation, and we should get 2 solutions. Moving on to another example, and if I just clear all the drawings. Now here it's slightly more trickier because we're dealing with a negative number, but that's not going to change our answer too much. So whereas before we would have done x plus half of b, now we're going to do x minus half of b because we have a negative sign here. So this is our b term, and the reason why this is our b term is because, remember, all quadratics are written in the form of ax squared plus, or in this case minus, bx plus c. So c is 1, b is 6. So it's going to be x minus half of b. So half of b is going to be 3 squared minus, again, half of b squared. So that's going to be minus 9 plus c is equal to 0. x minus 3 squared minus 8 is therefore equal to 0. And this would be our answer. So we've written the question in the form that they've asked us to do so. And that's it. And again, we can solve this. So I'll have a go at solving this. So what we'll end up with is add 8 to both sides to get rid of this minus 8. So add 8 to both sides. We'll have x minus 3 squared is equal to 8. We want to get rid of this square, so we'll take the square root of both sides. We'll end up with x minus 3 equals plus minus square root of 8. X is therefore equal to, we want to get rid of this minus 3, so we'll add 3 to both sides. So x is equal to 3 plus the square root of 8, or x is equal to 3 minus the square root of 8. And we can write our answers like this in a non-calculator paper, or if you had a calculator and they actually asked you to write your answer in decimals, type this into your calculator and write the decimal version. But usually if you were to write your answers like this, that would be perfectly fine. And you will need both solutions. You will need to write down both this solution and this solution here. All right. And moving on to our final example. So if I clear the drawings, it says write x squared plus 10x plus 3 in the form of x plus a bracket squared plus b. So again, another complete the square problem. So this is in the form of ax squared plus bx plus 3. So our answer is going to be x plus half of b. So that's going to be 5 squared minus half of b again squared. So that's going to be minus 5 squared is 25 plus whoops, I've written 3 here, that should be c. Although in this example, 3 is c. Plus 3 is equal to 0. And then what we'll end up with is x plus 5 squared minus 22 is equal to 0. And this is going to be our b value, and 5 is going to be our a value. And again, we can solve this. So what this would look like is x plus 5 squared is equal to 22. Remember, we have to add 22 to both sides to get rid of this minus 22. So we're adding 22 to both sides. Then we want to get rid of this square. So take the square root of both sides. We'll be left with x plus 5 equal to the plus minus square root of 22. Then subtract 5 from both sides to get rid of this 5 here. X is therefore equal to minus 5 plus the square root of 22, or x is equal to minus 5 minus the square root of 22. And that's it. So you can, like I said, remember these problems or do these problems using the formula where what we do is x plus b over 2 squared minus b over 2 squared plus c. You can remember this to complete the square, or you can think about it using the geometrical methods that we explored earlier. So if you want to understand the geometrical method better, I would suggest you go back to the beginning of the video, pause it, and really try and get an understanding. Because if you forget this method, or if you forget this formula, you can actually solve these problems using geometry. Thank you for listening, and I hope you have a very good day. Bye.